For triangles, there's a couple rules over here that we need to know for triangles. First will be all angles must add up to 180. So the angle X, Y, Z over here, so let's say this is angle X, Y, and Z, they must add up to 180. That's first. Secondly, we know that the area is 1/2 times base times height. And for a triangle like this, that would be your height over there, and this would be your base. And lastly, the shorter two sides of a triangle must add up to be longer than the third side. So shorter two sides must add up to be longer than the third side. Now, another fact would be opposite sides correspond to opposite angles. What exactly does that mean? That means that this angle over here corresponds to this side. This angle corresponds to this side, which is the opposite of it, and this angle up here corresponds to this side over here. Now, if I know that this is 8, the length of this side is 8, the length of this side is 10, and the length of this side is 12, I can see that this over here must be, let's say that this is X, this angle over here, must be the shortest, or sorry, not the shortest, but the smallest angle, since this is the shortest side. Since this is 10 and that's the middle, out of between the 8, 10, and 12, this must be the second biggest angle, Y, and the biggest angle must be Z, because that corresponds with 12, and 12 is the longest side. So opposite sides correspond to opposite angles. Next we have isosceles triangles. Wow, I really butchered the spelling of isosceles over there. So isosceles is not spelled that way. There's a C over there that I'm missing. But anyway, isosceles triangles, just two sides are the same. So 6 and 6. This side could be anything, but not 6. If it was 6, that would make an equilateral triangle, which we'll talk about next. But in isosceles triangles, two sides are the same, and since this side and this side are the same, this side corresponds to this angle, and this side corresponds to that angle, which would mean that this angle and this angle are also the same. Alright, and excuse me for my sloppiness on this page, but I think you guys will forgive me. So let's go to this one now. This one is equilateral triangles. Equilateral just means that all the sides are the same. So this could be 3. That would mean that this and this have to be 3. So if all the sides are the same, that means all the angles have to be the same as well. And if you know that these 3 angles add up to 180, that would just mean that these all angles are 60, 60, and 60. Alright, and the last thing I have here is the Pythagorean theorem for triangles. Whenever you're 90-degree angles, we can use the Pythagorean theorem, which is just a squared plus b squared equals c squared. This is my a, and that's my b, which are my two legs, and c is my hypotenuse, which is always the longest side, and that's the c right there. Let's do a quick problem for the Pythagorean theorem just to make sure you understand that and have a good grasp of that. So over here I have a triangle. X is one of my legs, 4 is another one of my legs, and 5 is my hypotenuse, which would be the c. And our goal here is to solve for x. And one more time, I'll write it down. You know that a squared plus b squared equals c squared. So over here, I don't know what the a is, which is the x. So instead of the a, I'll just replace that with the x. That'll be x squared. My second leg is 4, which will be 4 squared. And c in this case will be 5, which will make it 5 squared. So x squared, let me just take this up here. X squared plus 16 will equal 25. Subtract 16 on both sides, x squared will equal 9. And if I square root x, that will give me 3. So we know that this side is 3. On the SAT, whenever you have a 90-degree angle, there's another thing, the SAT, just a little side tip, it's called special right triangles. 3, 4, 5 is a special right triangle. Since this side is 3, this side is 4, and this side is 5. So if I knew about the special 3, 4, 5 triangle, and if I wouldn't have to do this whole, all the a squared plus b squared equals c squared, because I would automatically know that this is 3, 3, 4, 5. So another variation of that could be if I double everything, I can also have a 6, 8, 10 triangle. So that just comes from 3, 4, 5, me doubling everything here. It's like 3, 4, 5, 6, 8, 10. Just some special right triangles to speed up the process.